So the title of this is AI for Mixed Model Line Design. Some of you, I know because I know you, some of you are familiar already with mixed model line design. I know what we mean by that, but I'll give a quick definition of what that is, so we're all on the same page. And then we'll jump right into, over the last, say, 2 months or so, what has actually happened in the world of AI, and then what are some of the things that we're working on to, to use it, take advantage of it. Super. So here's our agenda. I'll start with just a one slide, one page definition of what is mixed model line design. Some of you may know what it is, but maybe you're not familiar with the term, the terminology. For others, it might be a new topic altogether. And then I'll cover what's new with AI in a couple aspects. There are literally hundreds of things that are new, but I'll talk about a few, mostly related to how we're using AI. And then we'll talk about mixed model line design more specifically and in the current state. So things we're doing right now that we've implemented right now using AI. And then a little bit of speculation in terms of where we see things going in the future using AI, so future state. And then I want to spend a little bit of time in the webinar going through the mixed model line design method that we follow. So we have a roadmap, we have a step-by-step process that we follow, and I'll have to do this fairly quickly because it could take, the rest of the day, but we'll go through our methodology, the steps, and then how AI could be applied to every one of those steps with the goal of automating as much as possible the entire mixed model line design process, with a single click or a few clicks, but automating that entire process, which normally takes weeks to months and sometimes more than that amount of time for manufacturing engineers and lean specialists to do that, complete that work, and maybe convert it down to really a very short amount of time. So here's what we mean by mixed model line design per se. So I'll just read it off to you here. Mixed model line design is a manufacturing strategy or methodology maybe that allows for the production of multiple product variants on a single assembly line or a single production line without the need for changeovers or significant downtime. And this approach is essential in today's market where customization and variability are highly demanded by customers. So mixed model line design aims to balance the line to handle various products with different work content times, and ensuring efficiency, so productivity, flexibility, so you can build different models without choking and dying, and high productivity. So there we go. And we should mention quality as well, right? 100% quality. So that's it. Now, this maybe sounds more mysterious than it is because most manufacturing companies of discrete products are mixed model manufacturers. So a classic example would be the automotive industry, where you have different models and different options for those models that have to go down basically the same line. But a lot of industries fall into this category as well. So it's not anything that's very rare or unique. Material handling products like fork trucks is an industry that we're fairly heavily involved in. Electronics, sensors, you name it, there's a whole long list. The industries that are not as good a fit for mixed model line design are those that are process type industries, like an oil refinery, where basically things are flowing, but it's all very highly automated. And once you've built it, there are limited opportunities to change it. So what we're looking for typically with mixed model line design is a mix of machines and people doing work. And that's the sweet spot for the mixed model line design method. Okay, so I hope we're all together on the same page with that. Now I'm going to jump in here briefly and just give you a little public service announcement. If you're interested in finding out more about mixed model line design and you're not that familiar with it or you want to learn more, we have a couple options for you. We actually have partnered with Toyota Material Handling here in the United States. In Columbus, Indiana is their main factory. And so 4 times a year, they have been willing to open their doors to us for us to use their training facilities, and they host a couple factory tours, 2 factory tours, some Q&A sessions with the Toyota ambassadors or the Toyota experts. And so it's a great experience. It's a 3-day workshop, and the next one's coming up pretty soon, but we still have a few seats left on August 6th through the 8th. So this is like a life-changing experience. It's really, really great. Spend 3 days inside probably the best example of mixed model manufacturing that I've ever seen. So there we go. That's one great opportunity. Now, if you can't make it to the live class at Toyota, we have an online version of the same workshop hosted in our Lean Design Studio. So if you want to find out more about that one, just go to leandesignstudio.com, and there's an information page that will pop up, and you can see what's available there. So not just mixed model line design certificate courses are available there, but also mixed model material flow. So the 2 wings of the bird. Right, so with that aside, let's get into it. So what is new with AI? Well, again, a lot. I subscribe to 3 AI newsletters that come out every day. And I subscribe to a number of YouTube channels that specialize in just keeping on top of all the changes. And those YouTube sites are sending out new videos, publishing new videos every couple days, if not every day. So it's just like crazy, industry just moving ahead at full speed. Now, I don't use all these tools, and my use of AI and our use of AI in Leonardo Group is primarily with 2. One is the famous, probably the best known ChatGPT, and the latest one is ChatGPT 4.0. O stands for Omni. And that came out, I don't know when the date was, maybe a few months ago, became available. So this is the latest and greatest version of ChatGPT. And Omni means, it's capable of not just communicating and processing text, but also video, images, audio. So it has, capabilities that are quite amazing. The other one that we use often, or I use often, is Claude.ai. So it's a competitor to ChatGPT, basically. And the latest version of Claude is 3.5, called Sonnet. And it came out, I think, just a few weeks ago. It's newer. And I use Claude and ChatGPT for different purposes. And I'll go into a little more detail there about when I would use one versus another. Now, in terms of our use of these 2 tools or involvement in the AI world, there's one that I'm excited to share with you, tell you a little bit about. It's called the AI e-learning Power Pack. And I'll tell you about that in an upcoming slide. We're also spending quite a bit of time with a company called Retrocausal AI. I'll tell you about that. And Retrocausal is a service provider, AI-based products, and it's kind of on the leading edge, I would say, of applying AI to manufacturing, and specifically to lean manufacturing. So I'll tell you a little bit about that. Now, what I won't be talking about in the webinar, and it's very interesting stuff, I love it, but advances in AI related to image creation or video creation or audio and music creation. If you've explored any of these at all, you know that the advances are coming hot and heavy. There are a couple sites that generate music, again, based on a text prompt. They'll generate songs and lyrics and all kinds of things. I'm not sure if that's good or bad for the music industry, but in any case, that's what's happening. I will not be touching on those. That's way beyond our focus here. Okay, so let's shift a little bit and talk about ChatGPT 4.0. This was an announcement from the parent company, OpenAI, about ChatGPT. And what they said was ChatGPT, the current version, is at level 1 on a scale of 1 to 5. It's at level 1. So that's kind of scary, isn't it? Because it's pretty good already in a lot of ways. But the company OpenAI says that they're getting closer to level 2. So a chatbot or a ChatGPT with the level 2 intelligence is about the same level as someone with a PhD or doctorate. higher intelligence. So basically, this is just an incremental improvement over what we have now, but it's going to get smarter, and they're getting closer to what they call level 2. Now, what happens beyond level 2? Level 3, AI can complete tasks on behalf of a user. So we can assign work to level 3 AIs, and they can more or less autonomously go out and do that. And we're touching on some of that already, but that would be things like, go book my travel plans for my next vacation. And it can go out and accomplish a lot of these things without too much help. So that's interesting. Level 4 means AI can create innovations. So up to that point, AI is kind of doing what we ask it to do, but it's not getting creative. And at level 4, apparently, they're saying it can actually come up with innovative and ideas that hadn't been offered or suggested ahead of time, or maybe taking what it's already learned and been trained in and expanding on that. Whereas up to now, it's not really expanding beyond what it already has been trained in. And then level 5, the ultimate level, highest level for their scale here, OpenAI scale, is AI can perform the work of entire organizations of people. So I'm not exactly sure what that means, but I'm assuming it means that AI could take over your accounting department, and AI could take over your sales and marketing department, and basically handle most of those functions. All right, now how soon is all this happening? Well, OpenAI's prediction, which may be optimistic, or it may be pessimistic, or too conservative, is within 5 years. We'll be at level 5. So that's really unbelievable when you think about it. So I guess what the lesson from this is that the changes we've seen so far, the power of AI that we are taking advantage of currently, is just scratching the surface of what's coming. And we can see this again happening every day or every week. Okay, so Claude AI, the other one I use, as I mentioned, the latest version was just released a few weeks ago. And I use Claude probably at least half the time when I'm wanting to use an AI chatbot kind of function. And the reason for that is Claude, in my experience, and this is entirely my personal testimonial, seems to be better at writing or better at language than ChatGPT. Not that ChatGPT is any slacker, but Claude does a good job of communicating and writing, reasoning, as it said, so that the increased strengths of Claude AI in this latest version are as, let's see, what is the company name? I forget. What they've said about Claude AI is that the reasoning capabilities have been improved significantly. And also Claude doesn't generate images, but it will analyze images. So I've done things like, and you can try this yourself, upload a value stream map. And Claude will very accurately tell you what's on that map, where the delays are, what the processes are, how they're connected, work content, opportunities for improvement, Kaizen burst analysis, based on a picture. All you have to tell Claude is, look at this picture and give me a complete analysis of what you see. And it's quite eye-opening to see, how good it is at just doing something like that. So all kinds of opportunities there. Now, so whenever I have some writing related stuff, I want to generate a white paper or some emails or something like that, I would typically go to Claude instead of ChatGPT. Now, ChatGPT, as I said, the latest version is 4.0 Omni, and this has been a significant upgrade. And I think that the OpenAI company has been adding a lot of features that they're not on the screen. You don't really see them when you connect to ChatGPT. But if you go to platform.openai.com or .ai, I forget which one, you can see all these additional features. So this new version has text, images, and audio. That's the O part of Omni. Better reasoning, better intelligence, I guess. Bigger context windows, so you can share more information, more words or content. It has a voice mode and a vision mode. So currently, if you load the ChatGPT app on your phone, it has a voice mode. So in other words, you can ask questions and get answers with audio. But it's kind of old style audio. It takes your voice, it converts it to a text, sends it to ChatGPT. They respond to the text, and then they come back with text, and then the text gets translated back into audio. So, there's some delays. It's not like real-time responsive, but pretty interesting. And vision, just on your phone, so far, it will not access your camera on your phone unless something's changed in the last few hours. But you can upload images similar to Claude. Now, if you're curious about this, just do a Google search on ChatGPT 4.0, and OpenAI has released some videos sharing the actual capabilities that are coming. And what they've said is, hey, these are being released incrementally, but apparently they're already here. They're just not being released to everyone, in one shot. So if you want to watch those YouTube videos on the release of this version of ChatGPT, it's really amazing. Because any of you that have seen that movie Her, with Scarlett Johansson's voice, it's kind of like that, where ChatGPT on your phone can use your camera, you can point the camera at things, and it'll tell you what it's seeing, and of course you can talk to it, and there's no delay, between the response time is almost instantaneous. So it's quite amazing, but we just don't have that yet. But they demoed it in these videos, and it's quite mind-blowing. Now, one thing we do have is something called assistance. This is in ChatGPT, and assistance is really pretty powerful. And so let me share with you what that is, latest development. So an assistant, you can get access to assistance if you have the paid version of ChatGPT, not the free version. But if you go there, you can go to platform.openai.com/assistance. And if you're not logged in, it'll ask you to log in. So there you are. And what you can do is define an assistant, or sometimes these are called personas, personalities, or avatars. You can create them. You can assign them a name. You can assign a image if you want, like a picture of your avatar. And then you can share content with the avatar, documents. And the basic thing is you can train your assistant in your content. And so this has been really helpful for us because we have a specific methodology. And so when we're using assistants, we don't want ChatGPT to go out and take whatever information it's gleaning from the internet and using that in their responses. We want our assistant to use our information. And so this is really powerful in that sense. And you can create unlimited number of assistants, maybe that are specialized in different areas. So you could have an Obeya sensei, a specialist or assistant, or you could have someone completely specialized in mixed model line design or material management, whatever you like. And you just feed that assistant your specific content, assuming you have it. Now, there are some tools like this already available. There's one called Custom GPT that we've actually been using, but now it's built into to OpenAI, right, to ChatGPT, which is pretty amazing. So how are we actually using that? Well, currently, like today, I came across this tool that we're starting to implement by a company called Training Spark. So what this tool does is it allows us it just kind of helps us or automates the process of using assistants in some applications that we have. So our training database, the Lean Design Studio, is a WordPress site. And within WordPress, we're using this plugin called LearnDash, which is how we enter our courses, lessons, certificates, quizzes, all that stuff is in LearnDash. So Training Spark allows us to use the assistants and integrate them into our lessons. So in 3 ways, actually, and they're listed over here on the left. So we can set up AI-powered conversations. So that's like a chatbot kind of mode. Reflections is a quiz mode where the assistant will actually ask you, the student, about your level of understanding and ask you to respond. Not just in a multiple choice format, but actually in text format. Tell me, explain to me your understanding of this or that. So that's the second very intriguing opportunity. And then virtual tutors. So again, the assistant can be the instructor if you need additional clarification on any of the points. The assistant will teach you, within the lesson itself. So we're pretty excited about that. It's extremely powerful. I think it's going to make online training much more interactive, much more engaging, and we can have a lot of stopping points within a lesson where the AI can actually engage with you and make sure you don't get too far down the road if your understanding is not clear up to that point. So I think I'm very excited about this. I think it's going to be helpful. And Training Spark has done a good job of their tutorials and their training materials too, to show you actually how to set this up. So really excited about that. And it's based on the OpenAI assistant functionality that was just added right in the latest versions. Okay, so that's just we're doing many other things with AI, but I just wanted to share those few with you with the time that we have. Now, what's coming up? So there were 2 timeframes I wanted to look at in terms of the evolution of AI as it applies to the world of lean manufacturing or factories, Toyota production system, that kind of world. And one of them is either now, it's available now, or it's available soon. Now or soon. And then the second one is longer term. So not really available yet, but we see it coming, right? And there are companies and organizations working on this, but we don't see it happening in the next, say, year or 2. Might take a little more time, hopefully. So let's take a look at some near-term advances that are either available now or soon. So factory real-time monitoring and adaptive control. So this is where I want to refer you to retrocausal.ai, this company I mentioned earlier, because that's one of the things they're working on. Retrocausal was started by some Microsoft folks who were world leaders, really leading edge specialists in video and image, vision technology, I guess you could call it. And so retrocausal is sensorless. It doesn't require you to install a bunch of sensors or what they call the Internet of Things kind of tools. It actually relies primarily on just looking, camera. And so one of the products they have, is retrocausal has, is this real-time monitoring where you can train the AI in work, and then the AI can actually observe people doing the work and either provide guidance in terms of the sequence and the steps, or provide instructions if they need additional help, and provide like a quality inspector if they do the work incorrectly or out of sequence. So you may have heard of this before, but that's becoming much more easy to implement because you can train the retrocausal AI by doing the work, right? So it watches the work, you do a certain number of iterations, and then it'll analyze the steps and be able to take it from there. So this is, I guess we could say this is already available now. But my thinking too is that if this phone-based version of ChatGPT can see and can analyze and is as smart as a PhD, doctorate, then I can see similar applications happening just with your cell phone, right? Pointing at some work and being able to do some real-time monitoring and other uses. Okay, so that's one that's coming, that already is here to a certain extent and is only going to become more common. And this, by the way, is especially important for companies and organizations that have a high turnover, where training becomes a real problem. You know, the expense of training new people. And if you can train the AI and then have the AI train people in doing the work, that's clearly a savings. Next one, predictive maintenance and self-healing systems. What we mean by that, and this is here already, by the way, is the ability of the AI and machine learning to monitor the performance of equipment, for example. One that I read about recently is a sensor that on a lathe or some kind of a piece of machinery that monitors the vibration and the sound. And through machine learning, it can detect when that changes and detect when a tool is wearing out, for example, and trigger like maintenance or repair ahead of time. And by self-healing, we mean if you can do that skillfully and anticipate problems through machine learning and through AI, then the amount of unplanned downtime could be reduced dramatically, right, or eliminated. So you may still need to do maintenance, but you could do it in off time, ahead of time, and not experience downtime during production hours, right? So that's kind of what we mean by self-healing. It can repair itself or detect problems and do it way ahead of time. Collaborative AI systems. So again, this is kind of what we have it already to a certain extent. By collaborative, I mean we have an engineer, maybe someone like yourself watching this video, and you have an assistant, and that assistant could be on your phone or it could be on your PC. Probably in the future, it could very well be on your phone. And on your phone, it has access to your camera, to your microphone. You can speak, you can talk in real time. And so if you're an engineer, you go out on the factory floor, you can actually engage in process improvement activities by pointing your phone at a workstation, have it watch the work, and then come back with ideas for process improvements that could be made. Now, so far in our discussion, you, the engineer, would have to make those changes, but that could be a partnership or a team effort. And that's happening, again, as I said, this is happening already to a certain extent. You can take photographs today, feed them to Claude AI, feed them to ChatGPT, ask them to do some analysis. You can also feed video. So we're getting very close to that, but I just see it becoming more and more easy to do here in the near future. And how near is the near future? Within the next year, I would say. This will become much more common. Now, factory digital twins. This is another thing that exists today. What do we mean by digital twin? Well, this is already being done. It has been done for some time, but with the introduction of AI, it becomes much more sophisticated. But what we're talking about with a digital twin is a digital model of your physical factory. And again, you can go onto YouTube and do a search on digital twin BMW, and you'll see an amazing video. It's a partnership between BMW and some of these software and hardware providers to create a digital twin of one of their factories. I'm not sure where, probably in Germany. But it's a digital twin that actually runs. And with AI, there's a lot more sophistication in terms of how the entities, like the people in there and the machines, are actually operating. So with a digital twin, you can test improvement ideas. You can validate production plans and schedules. You can test capacity, all in the digital twin, and not have to experience surprises, quote unquote, in the real world with your physical copy of the factory. So again, there are quite a few companies that are excited about this. Right now, though, my impression, if you watch this YouTube video, the impression is going to be, oh my God, this is so complex to build this, to create this. So maybe BMW had the budget to do it, but this is not going to be something that an ordinary organization would necessarily be able to even do. But I see that changing, right? That's going to be changing as AI starts taking over more of this development work. So in the future, I would see I mean, extreme case is every factory would have a digital twin. You build a factory, you build the digital twin at the same time. Or maybe you build the digital twin first, and then you build the actual physical factory. I could very easily see that. And that's becoming more accessible if AI does the heavy lifting in terms of building the digital twin. Okay, dynamic line balancing. Again, this is something that probably is already here, but could get better, could get more sophisticated. What we're talking about there is in a mixed model line, you have different products with different work content, different sizes, et cetera. And so when you're trying to run the line, the order of the products going down the line really makes a big difference. And so analyzing the work content, if you don't do it skillfully, you could have several products, for example, that are high work content that create a bottleneck in the line so that downstream from those, high work content products, the line starts drying up. People don't have work, they're waiting. And above, the line is filled up, it's blocked. So by doing skillful sequencing or production planning, or at the design stage, line balancing, you can improve your throughput and your productivity significantly. And so this is something that most companies kind of know intuitively, and maybe they have some sequencing rules that they apply, but this is a more sophisticated approach to that. And it could be tremendously helpful in terms of the order of production and sequencing. And last one is product mix analysis. Again, we do this today manually, but we're talking about our family of products that we're going to use to design this mixed model line or mixed model production line. And we have certain guidelines, certain ways of analyzing the variability that we see there, but that product mix analysis could improve dramatically with the assistance of AI. As long as we give AI some instructions, and then it can take a list of products and characteristics of those products and really do a thorough analysis. So that'll be helpful for us as well. Okay, so that's either happening now or it's kind of sort of happening now, but it's going to get much better here in the next, say, year or so. Now, what longer term advances? So first one, practical AI-empowered robots. Okay, you're wondering when I was going to talk about that, right? So far, we've just been talking about, a computer screen, and any kind of engagement with the world would have to be done by us. But that would change if we have practical meaning affordable and functional AI-empowered robots. So I'm going to jump a couple slides here and show you what's going on with that. Again, just scratching the surface. I don't really know what's going on with that, but I know about these couple things. First one is called a Unitree. That's the company. Unitree G1 is what they call a humanoid agent, AI avatar, and it can. I've seen videos of it picking up an egg, so it can manipulate things very well. It's a very flexible. It is actually faster, moving faster than some of the other ones I've seen. And most interesting, look at the price. It says the price $16,000. So not $160,000, right, as you might expect. So that's one thing, and it's Chinese, I should say. So this is a Chinese robot, but that is something that's out there. The other one that you maybe have heard of is our American version of this. This is a Tesla Optimus. So the Optimus Generation 2, I guess, came out in December. Maybe there's a Generation 3 by now. I don't know. But I have seen that these robots are actually working today in some Tesla factories, probably in kind of a prototype or test mode, but they're working autonomously. They're doing their thing, right? They've been instructed and they're working on, look like an assembly line. So the other thing about the Tesla plan, their vision, I don't know what the cost of these things is now, but the plan, according to Elon Musk, is to get the cost down to around $20,000. That's retail, right? $20,000. And what he said was, and I guess I kind of believe him, if we get the price of these things down to these AI robots down to $20,000, what Musk said was, this is going to be so much bigger than electric vehicles, than the Tesla cars, because everyone's going to want one. Why wouldn't you want to have a helper around the house? You know, as long as it does actually help. So what he said was, this could be many times, orders of magnitude, bigger deal than the electric cars, electric vehicles. So we shall see. But things are moving ahead with both of these things. Both of these robots already exist, and there are probably many others. So that's happening, right? But it's just as of today, I just don't think it's fully developed. So, and I think this is going to take more time than some of these other things to really get to a level of maturity where you could just go down to your Tesla dealer and buy one, right? And bring it home, do some training on washing the dishes and cleaning the house. No, not quite yet. Second thing, longer term, but one that I'm personally interested in, and I'm going to share a little bit more about this in just a minute, is the fully automated lean manufacturing design process. So we have a methodology, but right now with humans doing the work, gathering the data, doing the design, blah, 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 all the, you know, if it's a very small project, you could get it done in a few weeks, maybe. If it's a full assembly line, I've worked on projects in my career that have taken a year and a half, maybe close to 2 years to complete. Now, a lot of that time, the 2 years was, acquiring equipment and those kind of long lead time items. But just the design piece of itself, is still a substantial amount of work. And especially if you have to do a line redesign. So let's say you have an assembly line and you need to increase capacity. So you already have the basic line in place, but you need to add some workstations, rebalance the line, recalculate takt time, all those items. And by the way, companies that do line balancing, line rebalancing, may have to do it several times a year in order to, because if they're trying to adjust the output of their lines to demand, as time goes on, they're going to be out of adjustment, either up or down. And so you have to rebalance the line. This is what Toyota does. And it takes a team of engineers this is at Toyota Material Handling, approximately 6 to 8 weeks to do that, right? To rebalance the line. So that's not a minor detail. That's not a small cost either. So I'm going to continue on here with this list, but I want to share with you what might be possible, maybe in the near term, maybe not the long term, to achieve this fully automated line design process. So stay tuned in this webinar. Next one, AI-based plan for every part. Could AI manage your entire supply chain? In other words, could AI know all the parts that you're consuming, all the characteristics of each part, that's planned for every part, plus all the vendors, plus have access to worldwide supplier information and supplier lead times, et cetera, and basically manage your entire supply chain, both within the factory floor and outside. So this is similar to the mixed model line design process, but for materials. Sure, I think that's going to happen. Because right now, by the way, let me share this with you. This was a little bit of a surprise to me, and people are upset about this. But some people are upset about this. But I asked yesterday, so hot off the press, I asked ChatGPT a question about something, and the answer I got didn't seem to be correct. I was asking it a question about the Tesla Powerwall, that you might have in your house. And the latest one is the Powerwall 3. So I asked it a question about the Tesla Powerwall 3, and the answer I got, I kind of knew was not correct. And so I went back and I said, hey, I don't think your answer is correct. Are you really using the latest information? And ChatGPT 4.0 said, let me check. And then there was a little message that said, scanning the web or something like that, scanning the internet. And then it came back and said, oh, you're right. The latest information is. So in other words, today, as we speak, ChatGPT 4.0 isn't just responding with information it was trained on. It has access to the internet. Now, I don't know how much or what the rules are, what the guardrails are, but it has access to the internet. And I proved that yesterday because it was able to go out, do a scan, and come back with current information about the Tesla Powerwall 3. So I mentioned that because AI-based plan for every part, It could be looking at every item you have, doing a scan of the internet for information on availability of that part from a worldwide supply chain perspective and coming back with some recommendations. So pretty, I don't know, scary? Oh, amazing? I don't know how to describe that. Number 4, AI strategic planning. Similar kind of thing where AI would have access to customers, your customer information, your sales information, your sales forecast, the technology of your industry and your products and where things are going, and information that may be available to us, but not easily. And get it very quickly and be able to put together an amazing strategic plan, for your organization. Could be quite amazing. What else do we have here? 5, adaptive workstation design. This is already happening to a certain extent with retrocausal.ai. They have one of their tools is called Kaizen Copilot. And Kaizen Copilot will actually look at a workstation and do some analysis from the point of view of ergonomics, the placement of materials, to reduce reach based on usage of those materials, and a host of other items. So that is starting to happen, but with mixed model manufacturing, where different products, in theory, are going across the same station, there are all kinds of great opportunities. For example, designing multi-product fixtures. Can we do that today? Yes, we can. But having been involved in some of those projects, it's not so easy. So we might get some help there as well. So that's going to, I'm sure, be happening. So when we design a mixed model line, every workstation is going to go through an AI analysis, right, to provide some recommendations in a host of different areas, with ergonomics and safety being one of them, or two of them. Okay. Next, automated VR simulations. If you've looked at any of the latest developments on video, AI created videos, it's getting scarily realistic. Again, based on text prompts, it's, the ability to generate images that are moving, videos that are realistic with shadows and lighting, and the shadows of a person walking in a puddle of water on the street and stuff like that. I mean, it's amazing stuff. So it's not a stretch to think that in the future, instead of creating, virtual reality models, that AI is going to create them for us, and then we can participate. So in a factory, this digital twin that we talked about earlier could actually be quite amazing, and generated primarily by AI. So automated virtual reality simulations are on the way. Again, these already exist, but they're not cheap and easy to create, and that's the difference. And number 7, intelligent models and model-based design. So again, it's kind of connected to digital twins, but models with a lot more sophistication. We've had simulation models for at least 50 years, I would say, in some form or another. A discrete event simulation modeling, even back to the days where people would take shoe boxes of cards and bring them to the data center. Simulation modeling existed in those days. And it's gotten more and more sophisticated, but now we're getting into the realm where the entities, as I mentioned earlier in this webinar, the entities in the model are going to start to have some self-awareness, if you will, and be able to act more and more realistically within these models. Whereas up to now, the models have been very rule-based. In other words, so if this happens, then do this. If this happens, then do this. In an AI-based model, it's going to be much more hyper-realistic in terms of the behavior of the machines and of the people in that environment. So we can pretty much count on that. All right, so all kinds of quite amazing things. And the thing that's most amazing to me is we're not talking about the year 2060. By the year 2060, we expect to see these things happening. I mean, if by level 5, the OpenAI level 5 is within 5 years, is what they're predicting, then a lot of these things would be within that time frame as well. So not just within our lifetime, but within our, within the next few years, which is quite amazing. All right, I'll skip over these slides. So I'm going to go really fast here. If you want to, I'll turn it on right now. If you want to download this presentation, I'm going to share. Okay, AI for mixed model line design. That's this PowerPoint presentation. You can get access to it. It's a PDF, and you download it. And the reason you might want to do that is because I'm going to have to go really fast here, but I just want to share with you what we're working on and what's possible pretty much in the near term to automate the mixed model line design process. So here's our process. I don't know if you can see this clearly on your screen. It's maybe a little bit small, but we've broken down the process of designing or redesigning a mixed model line into 9 phases, right, or 9 major steps, all the way from assessment and master plan. That's step 1. And then we go through analyzing the flow and then collecting process data, calculating tact and resources, designing the individual workstations and cells. And then we have what is this one? Brainstorming the possible layouts at a kind of a high level. So kind of cutouts, paper dolls, Post-it notes level. And then we have the creation of a simulation model. We're big fans of that. So we've incorporated that. And then creating a final design with CAD, dimensionally correct design. And then we have selling the change, which is basically creating a deployment plan, getting approval. I mean, up to that point, you haven't actually done anything. You've designed it. It's like designing a house. At the end of phase 9 in this process, you have approved architectural and construction documents from the architect, but you haven't built the house yet. So that's a whole nother roadmap to get into. But let's see what could happen. I'm going to click pretty fast here. What could we do? The question is to automate each one of these steps using AI. Okay, so step 1, assessment master plan. So we can use it for data analysis, assessing the current state. If you had that information, AIs can already do a really good job of analyzing that data, summarizing it, identifying the current state, identifying opportunities for improvement, et cetera. All of that is available today. And then it can also do some planning. And I think it's going to get much better at planning, but it can create a deployment plan for the design phase of this design. In other words, who, what, when, where, what are the tasks? It's going to be able to do that. And we can provide it as part of our training. I should mention each of these steps is going to require some training, right, from our part to the assistant by providing information. For example, the steps, the roadmap steps, the detailed roadmap steps, which are approximately 130. In our model, there are 130 detailed deliverables or steps, sub-steps. Okay, so that's going to be very helpful. That's going to speed that up tremendously. Step 2, analyze the flow. So based on the information, maybe from our company routings or even from images that we provide, AI can generate process flow diagrams. So every product is going to have a process flow documentation. What are the main processes and how are they connected in time? And the other thing is it can generate a summary of that information, which is what we call a mixed model process flow diagram. That's where we take all the individual process flow diagrams and combine them into one master document that includes all of the processes, all the potential connections, and then it can summarize that in a matrix format too with X. All of that can be more or less instantaneous. and normally it would take days to weeks, right, to complete that. Step 3, collecting process data. So again, we touched on this already, but there's a possibility of either using IoT, Internet of Things, sensors and devices to collect data, or maybe in the future just pointing your camera at the work and collecting the data if you don't have it already, or taking existing data and giving AI access to it. So that's an important step. That's a step we can't bypass in terms of the process, having good process data. So process steps, process times, demand information, and we already have the flow information. And then looking at history, it can do some forecasting to establish the capacity that we need in this design. So how many units a day do we need to build, at least based on past history and based on some future projections? Can be helpful there. So you can see I'm going pretty fast, but we have to just in the interest of time. Step 4 is calculating takt and resources. Again, these calculations are not difficult, and this is pretty much a no-brainer step that it can do already, I'm sure. Step 5, workstation design. Again, we've touched on some of these opportunities already, and retrocausal has some tools to help with this already, so this is not a stretch. But AI can assign work steps, that's line balancing, level load the workflow in a mixed model environment, incorporate ergonomics and safety considerations, etc. All of that can be either used as an assistant or just do the whole thing if possible. And then ergonomics is another important consideration that it can analyze. Okay, step 6, brainstorm process flows. Again, normally human beings are doing this, and human beings will still be involved, but AI can generate multiple layout options based on the information it already has, right? And based on the criteria that we train it in, it can offer a whole bunch of options, so that at a minimum, it's really going to speed up that process of looking at the different flow options, basically. And then simulation and comparison. Well, as part of this process, I would assume AI can experiment with different layout options and give us the differences, right, and the benefits of each. All right, step 7, modeling the flow. This is what I'm interested in. Today, we can build a discrete event simulation model. That exists. There are lots of tools. Maybe some of you have some experience with that already. But it takes time, right? And the learning curve is not short to really get good at building simulation models. That's why typically, there are companies that specialize in that. But I can see the point in the future where with the right inputs, AI could just not only build the model, but run it, right, within AI and give you the outputs, even to the point of doing visual, 3D animations. So, today this already exists, and today we're already taking advantage in our company of AI, right, to speed up this process. And one of the benefits of AI or automating this is that AI can run experiments for us and create a nice matrix of different possible outputs or outcomes on productivity, on throughput, et cetera, running experiments using these models, and kind of automate that process. Number 8, formalized design. So again, CAD-based layout creation. AI, I said, can automatically generate detailed CAD layouts in the proposed design. This does not, as far as I know, does not exist today. But with the proper training and sophistication and intelligence of the AI, I don't see why not. And that includes a lot of the details we need to have, like equipment placement, utilities. Where do those utility drops need to be? Where should the aisles be placed for optimum material delivery access? And all these other details that need to happen. Dock doors, where should the dock doors be? Where should the supermarket area be placed? These are all things that we do today as humans, but if AI has the intelligence and the data, it could potentially do these things for us. All right, and the last step is sell the change. This is basically creating an implementation plan or deployment plan. So summarizing the design phase, et cetera, and there's no reason why. If it did the initial plan, it can do something like this as well. So I appreciate it. It was going fast, but here we go. We've only got about 5 minutes left to wrap this up. So mixed model line design, automation, what's holding us back? Well, number one, and I'm not pointing my finger at any of you individually, but in our experience, most lean specialists or manufacturing engineers or even lean consultants do not know the mixed model line design methodology. And this isn't Leonardo Group's methodology. This is how Toyota designed their lines. It's how a lot of leading companies design their production lines, more or less, right? I mean, we have our version of it, but most, in our experience, a lot of lean people don't really know it. They couldn't pass an exam on how to design a mixed model line. So that's one obstacle. You have to get trained. You have to know that. And I don't think we're going to get around that anytime soon. So if you're one of these people, you need to, up your game in terms of mixed model manufacturing. Next one, every one of those steps that we just went through in our 9-step process. I mean, you could have a 20-step process, however you want to slice it, but we have a 9-step process. it's going to require training the AI or training the assistant in each of those steps. And the script or the training script is going to have to be pretty detailed and accurate. And so that's going to take a little bit of time. It's going to take some time, but that's how the AI assistant is going to know what to do at each of these steps. So that's something that needs to happen. It could be in the form of a long script, right? Describing all the considerations, things to think about, ways of doing things, formulas for calculating these takt time and resources, et cetera, all the gotchas that can happen. All that needs to be documented and shared with the AI for training. That's the second thing that needs to happen. And then the third thing is, typically an effort like this to automate the whole thing would have to be funded. That means someone has to pay for the time it's going to take for the subject matter experts to develop this content and do the training and do the testing, et cetera. So there are two ways to do that. One is you actually have a project and you have a budget, and so you kind of build this into the budget to do this, or you have an investment that you make, right? You spend your own money basically, or venture capital money or whatever, and you develop this process. So that's a possibility. But other than that, number 4, I'm saying not much. There isn't too much today that would stop us from doing this. And every month that goes by, it becomes more and more powerful, right? As AI gets more and more capable. So I can see this, as something to happen. So lessons learned from this webinar. Here we go. The potential for AI to fully automate the mixed model line design process is vast, with current and anticipated AI capabilities covering almost every aspect of the methodology, the 9-step process that I mentioned. While human engineers would still play a critical role in providing initial data and overseeing the whole process, AI could handle the bulk of the analytical, design, and optimization tasks. This would lead to a more efficient, adaptable, and robust production line design. So I believe that is true. That is true. Now, we may not like that if we're a manufacturing engineer, or we may not believe it, but I believe that's a true statement. So that's kind of what's happening, folks. It's the latest and greatest update. Now, if you want to learn more about this, just to come back to this, the next class at Toyota Material Handling in Columbus, Indiana on August 6th, that's on line design, the stuff we just talked about in detail, that I think every lean professional needs to get certified in, because it's the foundation of the house of lean. The house of lean has a base that everything's built on, and this is part of that base, is the industrial engineering / Toyota production system / lean manufacturing foundation. And so that's August 6th through the 8th. And there are the links. I think, Michael, you can put the link into the chat as well if you haven't already. Yeah, there we go. Thank you, Michael. And then in November, we're going to have a similar workshop, but focused entirely on materials. And we like to express this as the wings of the bird. The 2 wings of the bird. So we have line design or workflow design, and we have material delivery, right? Material flow design. So November 12th to the 14th. Same place, same factory, but different subject. And ideally, you would go to both of them. All right, so that's what we have. I think that's all I have for you right now. So again, thanks for those of you that are still here. Thanks for sticking with us. Hope you enjoyed it. Hope that gave you some food for thought. And I look forward to hearing from you. If you have any, if you're willing to share anything that you are doing with AI in this arena, I really would love to hear about it. So go ahead and shoot me an email. I'd love to hear more about it. But other than that, I think we are done. So again, one more time, thank you so much for hanging out, and